How's it going, everybody? In this video, I'm going to go ahead and walk you through the configuration of the initial part of our lab, which is going to be setting it all up, getting it up and running. I have to do it anyway, so I might as well just walk you through the syntax that I'll be going through in order to configure it. So the way this is going to work is we have all these devices above me that we're going to be working with. We have CSR1 here that's going to be acting as the internet router. We have 2 and 3, which will be acting as like the dual hub router design for the HQ location. And then we will have a total of 4 branch locations. So we'll be using a combination of site-to-site VPN. We'll be doing some like DMVPN between these guys, and then site-to-site VPN with ASAs, and how all that comes together. So that's my goal, is to get everything up and running from an underlay perspective, and then we can go ahead and we'll go through some of the configuration we need to do on CSR8 as an endpoint, and you can see all the IP addressing in the background that we're going to be using for all the loopbacks that we're going to advertise. So we're not going to get anything routing wise working in this video. We're just going to get the underlay configuration in place and then go from there. So let's go ahead and get this party started. On CSR1, we are going to hostname it, and then interface gig1.1/24, and then a quick no shut. And then go to gig 2, same thing. This will just be a 31 and a no shut. There it is. Just patiently waiting for it to pop up. And then we'll do gig 3. He'll be a 41, a no shut. This part does take a little bit to get going, but it goes by pretty quick. We'll do gig 4. This will be a 51, and then a gig 5, and then a 61, and then last but certainly not least 6 for 11, headed to ASA1 over there, and then a no shut. So that's all the interfaces there. We're not going to be doing anything fancy like BGP, at least not right now. I will be tossing that into the design at a later point in time, after we've gone through just using static routing to do some basic VPN connectivity, and then I will move to a VRF aware process at some point in the future to do some more advanced configurations, especially for those of you that are studying for the enterprise exams and stuff like that. I will be taking a deeper dive look at that, but that'll come down the road a little bit further. So we have all of that going. So we're just going to go ahead and do right on that. And then now it's time to move to this side over here. We're going to get all these devices up and running and get the IP addresses going, and then go to the right hand side and get all that stuff working. So on CSR2, host name is going to be CSR2, interface gig1 21.0.0.2/24, and then interface gig 2, give that a second to register. Gig 2, and then I'm going to use the 172.16.1.2/24, and then a no shut. That'll pretty much be all I need to do there. And do right. Pretty straightforward config on that one. CSR3, same thing. Host name is CSR3, interface gig1 31.0.0.3/24, no shut it, and then interface gig 2, IP address of 172.16.1.3/24, no shut that guy as well, and we're going to go ahead and Give him a second to come online. There it goes. And do right. Then we're going to go to CSR7. Host name is going to be CSR7. IP address of, interface gig1, IP address of 172.16.1.7/24. No shut it. And now we're going to have to configure a couple of loopbacks on here so that when we get routing up and running at some point in the future, we'll go ahead and type in interface loopback. I usually like to start off with a low number and work my way up, so in the event that I want to do some summarization or supernetting, I can do so. So I will start off on loopback 0, and I will, IP address is going to be 10.1.0.7/24, and then I will come up here and this will scale very, very nicely here in just a second. So I'll just come in here and do a 1.7 and start adding these guys up. Do a loopback 2, and then do a 2 in the third octet. Third, and then 3 dot. Simple as that. Do show IP interface brief. We have a couple of loopbacks. So now if I need to do any type of supernetting, I can take and do a like a /22 on those if I wanted to do so. That's pretty much that one. Let's go ahead and jump over to router 4 and get him squared away. So on router 4, host name is going to be CSR4. Interface gig1 is IP address of 41.0.0.4/24. And it's going to be a no shut on that interface. So give that a couple seconds to come online. The server this IKEv instance is running on has got quite a bit of load on it, so that's why it's taking a little bit longer for some of the stuff to work. We'll go to interface gig 2. IP address is going to be 10.4. In this particular case, I don't really have a clearly defined addressing structure set up, so I'm just going to use 4.8.4, considering it's going to be CSR4 to router 8, and I'll just do /24 and no shut the interface. Because what's going to end up happening is we're going to have every one of these interfaces come in, and I'm going to create a couple of VLANs on the switch. So the switch will have 4 VLANs on it. There will be a trunk link set on this guy to this interface, because I need some way of taking this router's interface and carving it up into 4 different subnets. I really can't do that without a sub interface placed instead of a VRF. So I will create 4 VLANs, like VLAN 4, 5, 6, and 11, for example. I'll make gig1/0 a trunk link, and that'll send CSR8 up there. We'll do router on a stick, but we'll do a per VRF breakup. So that's how that will work. And then I'm done configuring this guy, at least for right now. I may need to add a loopback address at some point in the future, but for right now, we're squared away. CSR5 is going to be the same process. Host name is going to be CSR5. Interface gig1 51.0.0.5/24. No shut it. Give that a couple seconds to come online. Interface gig2, IP address of 10.5.8.5/24. We're going to go ahead and no shut that interface. Bring that guy online, and that's pretty much all I need to worry about for right now. Go to router 6. Host name is CSR6. Interface gig1, IP address of 61.0.0.6/24. You guys might be wondering, well, what about a default route or something like that? That'll take me all of a couple of minutes to configure on a couple of devices, so I'm not overly concerned about that. But that, in my opinion, is not a bootstrapping configuration. That's going to be something, setting it up, the IP addressing and the remote management. Yes, that's a bootstrapping configuration. I may do one router that's doing a BGP peering that's VRF aware. So I may not want to go out of the gate with just all default routes. So we'll figure that out as we go. Interface gig 2, IP address is going to be 10.6.8.6/24. No shut it. And that's pretty much it. Once these interfaces come online, that'll pretty much be the extent of it. There we go. Do right that. And then last but certainly not least, we'll jump onto ASA1 to get him squared away. Host name is going to be ASA1. We're going to say on gig interface gig 0/0 be 11.0.0.11/24. Actually, I make that mistake almost all the time. No shut it. Name if is going to be outside. And we're typing interface gig 0/1 IP address of 10.8.11.11/24. No shut. Name if is inside. We're just going to save the config like so. Now my next step is going to be on switch 10. We're going to go host name is going to be switch 10. And we're going to type in VLAN 4, VLAN 5, VLAN 6, and VLAN 11. We're going to place interface gig 0/0 and VLAN switch port access VLAN 4. Switch port mode is access, spanning tree port fast. Gig 1, this will be VLAN 5. And then VLAN, gig 2, VLAN 6. And then spanning tree. And then last but certainly not least, gig 3, VLAN 11. And there we have it. So that's pretty much everything that we would need to have on those interfaces. Interface gig 1/0, switch port trunk and cat.1q, switch port mode is trunk. Do show interface trunk. Give that a couple of seconds to do its thing. And as soon as it comes online, we should be squared away. Do show interface or span. It's amazing that it's, even though it's an RSTP, it still takes a while. Now there is a spanning tree port fast trunk or network. You can do network, which is going to be basically a trunk, but you know, I personally don't like using the command if I don't have to. So we have that one. So I'm going to go ahead and do right that configuration, and now I get to go over to router 8, and did I not bring him up? Oh, that's right there. So now on router 8, this one's going to take us a minute because we have some configuration we have to do. Host name is going to be CSR8. And then what I'm going to do here is I'm going to create some sub interfaces. I'm going to create interface gig 1, no shut it. And then one of the first things I'm going to do is create VRF definition is going to be S4. The address family IPv4 unicast and IPv6 unicast. This will be VRF Lite. We have S5, 6, and then 11. We have all that. So now we have the VRFs created. So now I need to go to interface gig1 dot 4. Encapsulation.1q is 4. VRF forwarding is going to be S4. The IP address on this guy is going to be 10.4.8.8/24. And then we'll do 5. And basically wash, rinse, and repeat. 5.8.8. And then 6.8. And last but surely not least, 11. Encapsulation is 11. For VRF 11, and then the IP address of 8.11.8. So do show IP interface brief. We have those specific VRFs, those interfaces applied to VRFs. Do show IP route. You can see nothing is in a VRF. So now I can go in here and do show IP route VRF S4, S5, S6, and S11, and everybody is squared away there. So now if I wanted to create loopbacks, I could and put them in their individual into their individual VRFs. So the way that that would work would be, let's say interface loopback, I'll say let's see, we'll say 172.24. So we're matching on this particular loopback address, and I will say 0. And it's okay if I have that type of a numerical value, so I can just type in VRF forwarding is going to be S4. And then IP address in this case here would be 172.24.0.8/24, for example. Once I have all the legwork done for something like that, then I have it's created. Now if I hit the up arrow a few times and I create interface loopback 192.168.40 and hit the enter key, and then the VRF forwarding is S4, and then IP address of 192.168.40.8/24. Do show IP interface brief. Do show IP route VRF S4. You can see all the routes propagate. So just to show you again, loopback 172.24.0 interface. We can see that we've created a loopback that matches the subnet. We placed it in the VRF of S4. So now, if I wanted to do anything ping-wise, for example, CSR8 wants to ping CSR4, do ping VRF S4 of 10.4.8.4. Give that a couple of seconds to figure itself out, and the ping goes out and figures itself out. So we are squared away there with that. So then it would just be a wash, rinse, and repeat of what I've already done. So for example, if I was to come in here and do a, let's do an interface loopback 172.25.0, VRF forwarding is going to be S5, IP address is going to be 172.25.0.8/24. And then I come up here and do a 192.168.50. VRF forwarding is S5. IP address is 192.168.50.8/24. Do show IP interface brief. As you can see, I can quickly scale this, and it doesn't take a ton of time to do it. Do show IP route VRF S5, and there the routes are. So that's really, when I'm looking at a topology, this is my mindset. How can I make it relatively easy to get this up and running? So now I can run a VRF aware routing process like EIGRP, OSPF, IS, BGP, whatever the case might be, from these routers here to this router here. So all this will have reachability, and it gives me some flexibility in terms of scaling stuff out. So I don't have to have as many nodes on the network working in order to facilitate reachability. So that'll be some stuff that I take a look at in the near future when we start diving into the actual lab constructs and stuff like that, and you'll see that as we progress. So that is the setup, as you can tell. If you have any questions, please leave a comment in the comment section below. Until next time, guys, take it easy.